Hi everyone, in this presentation we will hit on a few of the high points of Chapter 7, which is called Energy Balance. This is certainly not everything covered in the chapter, as there are several other concepts of importance, so be sure to read the chapter and follow the outline so you don't miss any information that might be presented on the next test. First off, let's discuss the actual meaning of the term energy balance. This just means that energy input, or the foods that you eat with calorie containing nutrients, is equal to your energy output, or calories expended, or you might hear the term calories burned. That's also fine. Keep this visual in mind as we discuss energy balance. You can see here that if energy input equals energy output, a healthy weight will result. If energy input does not equal energy output, this will impact our energy stores, especially in the form of fat, and we'll discuss why in the coming slides. So keeping our scale visual in mind, like you see on the screen, let's discuss what happens when our energy balance scale tips in one way or the other. So a positive energy balance is when energy input is greater than energy output. This means you are consuming more calories than you are expending or burning. And when calorie intake exceeds calorie expenditure, the body stores this surplus energy as fat in adipose tissue. So, as a result, increased fat storage leads to weight gain, and over time, it can contribute to obesity. This fat is primarily stored under the skin or as visceral fat around your internal organs, the latter being more metabolically harmful, linked to conditions like type 2 diabetes, cardiovascular disease, and metabolic syndrome. Now, what happens when the scale tips in the other direction? In this case, a negative energy balance occurs where energy input is less than energy output. This means you are burning more calories than you are consuming. And when calorie expenditure exceeds calorie intake, the body taps into its fat stores to meet your energy needs. Therefore, stored triglycerides in your fat cells are broken down into fatty acids and glycerol, which are used as energy sources. This results in fat stores decreasing, leading to weight loss, and that makes sense. So, if you are in a prolonged energy deficit, it can result in significant fat loss. However, if it's too extreme, it may also lead to muscle loss and nutrient deficiencies, which is a very negative outcome. So, keeping on the topic of energy output, you should keep in mind the term thermogenesis, which is a metabolic process in which the body burns calories to produce heat. Now, our bodies use energy for three main purposes. The first being basal metabolism, also termed as your basal metabolic rate or BMR. It's essentially the minimal energy required for our bodies to support themselves in a fasting, resting but awake, warm state. This is the energy required by our organs to keep us alive, like your heart beating, breathing, and your brain activity, and all these things going on in the background. So to speak, they do require energy. This is the largest contributor to energy output at 60 to 80% of the total energy used by our bodies. Many factors do impact BMR, but the most important to remember is that people who have a lean body mass have a higher BMR, since lean body mass is more I cannot say that word, metabolically active than fat mass. So, the next concept to remember when it comes to energy output is physical activity. This is different from basal metabolism because physical activity is considered intentional, and your muscles are using energy to fuel muscle contractions. So, when it comes to physical activity, there's a broad range of energy loss. Those who are burning calories intentionally, like those exercising, doing running, lifting weights, or playing a sport, are losing heat energy through exercise induced thermogenesis. This can account for up to 15 to 30% of total energy expenditure. Now, non exercise activity thermogenesis refers to energy expended for activities that are not considered structured or intentional exercise, including daily movements like standing, walking, cleaning, gardening, typing, or even writing. Even though these aren't considered intentional exercise, they're still a very important component of total energy expenditure. Now, recall in the semester dietary analysis project instructions, if you have not worked on that yet, you are required to record all 24 hours of activity for the 5 days that you choose to record. This includes both intentional exercise and unintentional activities, since they both burn calories. I often have students turn in projects that just list, 30 or 45 minutes of weightlifting, or maybe they took an hour-long walk. This is not adequate. You can't just turn in 30 minutes or an hour of activity, because all your activities, sleeping, cleaning, showering, walking the dog, walking to class, these all account for expenditure, which is why you cannot compare your intake and expenditure without all 24 hours recorded each day. Now, the third type of energy output is the thermic effect of food, which is the increase in energy expenditure above your basal metabolic rate due to the process of digesting, absorbing, metabolizing, and storing nutrients. That accounts for about 10% of total daily energy expenditure, but can vary based on one's dietary composition and individual factors. So, in other words, as our textbook mentions, the thermic effect of food is like an energy tax that is being charged around 8 to 15% for the total amount of calories you eat to cover the cost of processing that food. Now, a very minor form of energy output is adaptive thermogenesis, which refers to the body's ability to adjust energy expenditure in response to changes in environmental factors, such as calorie intake, physical activity, or temperature. But this adjustment helps maintain energy balance against energy deficits or surpluses. A common example of adaptive thermogenesis is shivering. We don't intentionally do this, but it's brought about by our hypothalamus telling our muscles to contract when we are exposed to cold temperature. So again, be sure to read about how the amount of energy our body uses can be measured and how estimated energy requirements are determined. Also read the section in our textbook on assessing body weight. But shifting gears, I wanted us to look at how our body mass index, or BMI, is calculated. I'm sure you've heard that term before. This is the most commonly used weight for height standard and measures risk of disease for most individuals. To calculate your BMI, there are two methods, depending on if you are using the imperial system, which is the one we use in the United States, or the metric system. Now, for the purposes of this presentation, I'll go over the calculation using the imperial system. I have both formulas up here. Now, as an example, if we have a person who is 5 feet 11 inches or 71 inches total and who weighs 165 pounds, how would we calculate their BMI? It's fairly easy. You would divide the weight, 165, by their height, which is 71 inches, squared, which in this case is 5,041 inches squared. This gives us 0.032, but we must multiply by a factor of 703 to get our BMI, which for this example turns out to be 23. So let's go to the next slide to see where this falls in the BMI categories. So looking at the categories on the left, the person from our example would fall into the normal weight category, since their BMI was found to be 23. Now, BMI is an easy and inexpensive way to help identify both males and females who are at risk for health problems associated with underweight, overweight, or obesity. It can also be used in population studies to monitor trends in weight and obesity rates over time. However, there are limitations to BMI, since it does not differentiate between muscle, fat, or bone mass, which can lead to misclassification. For example, an athlete with a high muscle mass may have a high BMI, but low body fat. Another con is that BMI ignores fat distribution in the body. Recall that fat around the abdomen has more health risks associated with it, but BMI does not provide this information. It also can't be used on young children or adolescents, and someone's weight does not always indicate their health status, which can make BMI problematic. It is a great screening tool, but definitely not considered a diagnostic tool. So, again, I do ask that you read the chapter in full, even though I didn't cover all of it in this presentation. For instance, the section on weight control, these concepts may still appear on assignments or tests. If you have any questions about the concepts I discussed here or those I did not discuss, please contact me and I'm happy to help out anytime.